The life of our star began not with a bang, but with a whisper. 4.5 billion years ago, before the Earth, before the planets, before the very light of day existed in our corner of the cosmos, there was only a cloud, a vast, cold, molecular cloud of hydrogen and helium drifting through the dark vacuum, the remnants of older, dead stars that had exploded in the deep past. These clouds are the nurseries of the universe. They are cold, unimaginably cold, hovering just a few degrees above absolute zero. And they are vast, stretching for dozens of light years. For eons, this cloud hung in a delicate balance. On one side, you had the internal pressure of the gas, the thermal motion of atoms pushing outward, wanting to drift apart into the void. On the other side, you had gravity, the universal sculptor, the force that Newton described and Einstein refined. Gravity is the weakest of the fundamental forces of nature. It is trillions upon trillions of times weaker than the electromagnetic force holding your atoms together. But it has one distinct advantage. It is cumulative. It reaches across the infinite. It always pulls. It never pushes. And so, perhaps triggered by the shockwave of a nearby supernova, the violent death rattle of a neighbor, gravity began to win the war. The cloud began to collapse. As it collapsed, it began to spin. This is a consequence of the conservation of angular momentum, the same principle that makes an ice skater spin faster when they pull their arms in. As this colossal cloud shrank, it spun faster and faster, flattening out into a majestic disk. And at the center, the pressure began to mount. The gas atoms, squeezed by the relentless grip of gravity, began to collide. And as they collided, they generated heat. The temperature began to climb, from hundreds of degrees below zero to thousands to millions. This proto-sun was dark, shrouded in dust, glowing only in the infrared, waiting for a critical threshold. To understand what happened next, the moment of ignition, we have to journey into the strange, counterintuitive world of quantum mechanics. You see, for a star to shine, it must fuse hydrogen into helium. This is the engine of the cosmos. But there is a problem. A proton is a positively charged particle. And as we know from school, like charges repel. The electromagnetic force pushing two protons apart is ferocious. According to classical physics, the physics of the 19th century, the core of the sun, even at 15 million degrees, is not actually hot enough to overcome this repulsion. The protons should bounce off one another. Fusion should be impossible. The sun should not shine. So why are we here? We are here because of quantum tunneling. In the quantum world, a particle is not just a hard sphere, it is a wave of probability. Its position is not fixed. There is a tiny, vanishingly small, but non-zero probability that a proton can simply appear inside the nucleus of another, bypassing the barrier entirely. It is as if you threw a tennis ball at a brick wall, and once in a trillion throws, it simply passed through the bricks as if they weren't there. This rare quantum event, occurring thanks to the Heisenberg uncertainty principle, allows the protons to fuse. They bind together, releasing a positron and a neutrino, eventually forming helium. And in that process, a tiny amount of mass is lost. Where does it go? It becomes energy. It follows the most famous equation in history, E equals mc squared. Energy equals mass times the speed of light squared. Because the speed of light is such a large number, a tiny amount of mass creates a staggering amount of energy. This is the heartbeat of our star. Every single second, the sun converts 600 million tons of hydrogen into helium. And in doing so, it releases an amount of energy equivalent to exploding billions of nuclear weapons. every single second. This energy does not escape easily. It is born in the core, the densest part of the star, where the plasma is 150 times denser than water. A photon of light born from this fusion cannot simply fly out. It crashes into other particles, it bounces, it scatters, it is absorbed and re-emitted. It performs what mathematicians call a random walk. It can take this photon, this packet of light, up to 170,000 years to fight its way from the core to the surface. Just think about that. The light hitting your face on a warm summer afternoon was created in the nuclear furnace of the core, when human beings were just beginning to migrate out of Africa. It has been trapped inside the sun for the entirety of human history, only to escape today, travel 8 minutes across the void of space, and land on your retina. It is an ancient messenger. Once the star ignited, it entered the phase we see today, the main sequence. It is a stable star. It is in a state of hydrostatic equilibrium. This is a beautiful, violent ballet. Gravity is constantly trying to crush the sun into a point of infinite density. The nuclear fire pushing out is constantly trying to blow the star apart. They are perfectly balanced. For 4.5 billion years, this balance has held. It has allowed the protoplanetary disk to cool. It has allowed dust to clump into rocks and rocks into planets. It has allowed a blue marble to form in the Goldilocks zone, where water can exist as a liquid. It has allowed the chemistry of life to begin. But nothing lasts forever. The universe is governed by the second law of thermodynamics. Entropy must increase. The fuel must run out. We are currently halfway through the life of our star. It is middle-aged. But in another 5 billion years, the hydrogen in the core will be exhausted. The engine will sputter. The delicate balance between gravity and fusion will be broken. And when that happens, the true violence begins. With no outward pressure from hydrogen fusion to hold it back, gravity will take over. The core will collapse. As it collapses, it gets hotter. Much, much hotter. The temperature will rise high enough to ignite a shell of unused hydrogen around the core. The star will brighten. This intense heat will push the outer layers of the star outward. The sun will begin to grow. It will swell and swell. It will leave the main sequence and become a red giant. The transformation will be terrifying. The sun will grow so large it will swallow the orbit of Mercury. Then Venus, the beautiful morning star, will be vaporized, its atmosphere stripped, its surface liquefied, its very substance consumed by the dying parent star. And what of Earth? If you were standing on the surface of the Earth 5 billion years from now, assuming you hadn't already been boiled away by the increasing luminosity, you would see a sky filled entirely by fire. The sun would act as a wall of red plasma stretching from horizon to horizon. The oceans will have long since evaporated. The atmosphere will be blown away. The mountains will melt into slag. The earth will be a charred cinder drifting through the outer atmosphere of a dying god. Inside the core of this red giant, the pressure will eventually become so extreme that a new type of fusion begins, the triple alpha process. Helium atoms, the ash of the previous life, will be crushed together to form carbon and oxygen. This is a profound moment. The carbon in your cells, the oxygen in the air you breathe, the calcium in your bones, the iron in your blood. All of these heavy elements were not created in the Big Bang. They were forged in the dying hearts of stars like this one. We are quite literally made of stardust. We are the nuclear waste of a red giant star. But this helium burning is unstable. The sun will convulse. It will shudder. It will go through a series of violent thermal pulses. It will heave its outer layers off into deep space. This is the planetary nebula phase. It is a misnomer. It has nothing to do with planets. It is the final beautiful breath of the star. The outer atmosphere, rich in carbon, oxygen, and nitrogen, will expand into a glowing shell of gas, illuminated by the exposed, superheated core. From a distant alien world, our dying solar system would look like a jewel in the dark, a ring of emerald and sapphire gas, intricate, complex, and hauntingly beautiful, a cosmic flower blooming in the dark. And at the center, the core remains. Whatever is left of the sun will collapse one last time. But this time, there is no more fuel to burn. No fusion can stop the collapse. Gravity pulls it down, crushing it smaller and smaller. It shrinks to the size of the Earth, but it does not become a black hole. The sun is not massive enough for that ultimate tragedy. Instead, it is saved by a principle of quantum mechanics called electron degeneracy pressure. The electrons, squeezed so tightly together, refuse to occupy the same quantum state. They push back against gravity with a force that is not thermal, but fundamental to the nature of matter. The sun becomes a white dwarf. A white dwarf is an object of extreme physics. It packs the mass of the sun into a volume the size of the Earth. A single teaspoon of white dwarf material would weigh as much as an elephant. It is incredibly hot, glowing with a fierce white-blue intensity. But it is dead. It is no longer generating energy. It is simply radiating away the heat of its former life. It is a stellar ember, a tombstone marking the place where a solar system once existed, where a civilization once looked up and wondered. This white dwarf will shine for billions of years. It will cool slowly, agonizingly slowly. The white light will fade to yellow, then to red. It will become a dim crimson ember in the eternal night. And then, the final phase. As the heat bleeds away into the expanding universe, the white dwarf will crystallize. The carbon and oxygen interior will solidify. It will become, in essence, a diamond the size of the Earth, a cosmic diamond floating in the dark. Eventually, it will cease to emit any light at all. It will become a black dwarf, a cold, dark, dead object, drifting through a galaxy that is itself dying as star after star blinks out. It is a somber thought to think that this brilliant, life-giving ball of fire, this god of the ancient world, will end as a frozen rock in a silent universe. But we must not look at this with despair. We must look at it with a sense of privilege, because we are here now. We exist in the brief golden era of the universe, the stelliferous era, where stars shine and energy flows and complexity is possible. We are the universe waking up and becoming aware of itself. The story of the sun is the story of the triumph of order over chaos, if only for a while. It is a story that requires gravity, electromagnetism, and the strange rules of quantum mechanics to all work together in a perfect symphony. It is simply extraordinary. Just consider the chain of events. A cloud collapses, a star ignites. It creates the conditions for life. It manufactures the atoms necessary for life. And then, in its death, it scatters those atoms back into the cosmos to become part of the next generation of stars, and perhaps the next generation of living things. The death of the sun is not just an ending. It is a necessary step in the recycling of the cosmos. Without the death of stars, the universe would be a boring place, filled only with hydrogen and helium. There would be no chemistry, no biology, no consciousness, no one to wonder. So, When you feel the warmth of the sun on your skin, remember the journey that energy has taken. Remember the protons fusing in the darkness of the core. Remember the photons' 100,000-year struggle to escape. Remember the balance of forces that keeps the sky from falling. And remember that we are transient. Like the sun, we have a beginning and we have an end. But in the time in between, we can shine. We can understand. We can look up at the Milky Way, that river of light, and know that we are part of it. We are not separate from the universe. We are the universe. And that is the most profound feeling of all. As the great physicist Richard Feynman once said, nature uses only the longest threads to weave her patterns. So each small piece of her fabric reveals the organization of the entire tapestry. The sun is our thread. It connects us to the Big Bang, and it connects us to the distant future. It is a temporary victory against the cold, a momentary flash of brilliance in the deep time of the cosmos. But what a flash! What a magnificent, radiant, life-giving flash. And as we watch the sunset painting the clouds in violet and gold, we are witnessing the machinery of our existence. A nuclear reactor, 93 million miles away, holding back the dark. It is beautiful, it is terrifying, and it is home.